What's splashin'? Welcome to season 5, episode 3 of Siren Sundays with me, your host, Lashanti the Siren. This show is focused on speaking with researchers, scientists, and practitioners of environmental science and all things conservation. You are now tuning in to our conservation conversation, and today's guest is Catalina, who is a master's student of science, master's of science student researcher. I botched your entire intro.
You got it.
Master's of Science researcher at Dalhousie University. Welcome, Catalina. So great to have you on the show.
It's so great to be here. I mean, I've been watching these episodes go by week after week, and you asked me to come join you, and I almost hopped out of my chair. So so excited to be here.
Definitely. And I'm excited to have you. So if you can just introduce yourself to the viewers, your name, what you do, where you're at, brief intro, the fun stuff.
Yeah, so like Lashanti mentioned, my name is Catalina. I grew up in Abaco on a little key called Great Guana Key. And these days I'm finishing up my master's degree in biology at Dalhousie University, which is located in Halifax, Nova Scotia, in Canada, up in the Great White North.
Right. And right now we're having this cold front. And I know you're probably like, I'm used to the cold.
Yeah, I think we got about 30 centimeters last night, so it's white out there.
Really cold wind. We've got very cold wind. I hate it. But so glad that I know. That is true. It depends on what your body has become accustomed to. Mm-hmm. But so can you tell us a bit about your research?
Yeah, absolutely. So these days I'm working with phytoplankton. And so those of you at home who may not have heard that word before, I like to split it into its two portions, which are phyto and plankton. So those are both Greek, and phyto actually means plant, and plankton means drifter or wanderer. So that means that phytoplankton are floating plants. And that basically covers any organism that photosynthesizes in the water column, just like a plant, and also has no ability to move itself around on its own, for example, like a fish. So these guys are at the mercy of the currents, and yeah.
That's exciting. So what made you decide to study phytoplankton?
Well, I think my career path is pretty kind of interesting. So like I mentioned, I grew up on this small key, and especially through my childhood, I was in the bush, walking around barefoot in tidal pools, like scooping up whatever little bit of life I could get to take a look at. That's fish, octopus, seaweed, whatever, and kind of just observing. And especially through my childhood, one of the big events that happened was on my key, there was a big development, and that development is called Baker's Bay. And there was a big push from the locals, especially to make sure that development was not going to affect the ecology of the island. And so there were very big plans, and particularly one of the most concerning ones was for a 18-hole golf course, with the 18th hole being about 10 meters from the water, which is a problem because, as some of you may know, nutrient inputs from golf courses are not great for coral reefs, and Abaco does have quite a large barrier reef along the whole island. Mm-hmm. And so pretty much for the entirety of my childhood, I had scientists, policymakers, stakeholders, fishermen coming in and out of my home all the time for this movement against this development. And I met a lot of super interesting people who were doing this work, mostly, out of the goodness of their hearts and their want to devote themselves to the environment. And I think it really influenced me. And I think that's one of the reasons why I think I'm very focused on thinking about the marine environment and how we impact it and how it impacts us as well. So that was happening, and then in my 12th grade, I took a marine science class, which was, I think, probably 5 of us took it at my high school.
That's a lot. That's a lot for Abaco.
Yes, it is a lot for Abaco. And my principal actually ended up teaching that course, and it was so great. And he really did a lot of hands-on learning with us and took us out to a lot of marine environments. And it really just got me thinking like, wow, I need to keep doing this because it makes me so happy. Yeah, so I shipped myself up to Canada, got a degree in biology, and while I was there, I took a seaweed course all about just algae, and we were spending a lot of our time, walking around in the intertidal zone, collecting algae, looking at algae in the microscope, and it's just kind of crazy how this thing that not many people spend any time at all thinking about, have so much importance to climate, to people who eat these algae, and generally just biodiversity and ecosystem health. So I got really into taking a look at the things that were kind of underappreciated, and through that class, I ended up meeting my supervisor, and now I'm doing a master's with her. So that's kind of how I got there.
That's exciting. And I definitely love seaweed. It's one of my favorite snacks. So it is interesting to hear that, this kid from Abaco ends up in Canada studying it. And we hope to have you come home soon. Maybe you'll do a PhD. We'll see. But just curious. So what is your research exactly? So what do you do when you are looking at these phytoplankton?
For sure. So my group works in under a subfield of marine microbiology, so understanding microbes in the ocean. And specifically within that, we study trace nutrient biogeochemistry. So that's kind of a mouthful there. So I'll break it down again.
Awesome.
So biogeochemistry, we've got bio, geo, and chemistry. So the biology, the geography, and also the chemistry. So the study of how biology influences the movement of chemicals around the globe.
Oh, I love that.
Yeah.
Should I pop up the video with the globe?
Yeah, that'd be great.
Awesome. Because I've been excited to hear you talk about this. Looks so cool. Like a great little painting, but tell us, what are we looking at?
Yeah, so there are folks out there who can take satellite images, and from ocean color, they can tell what kind of phytoplankton are living in the ocean. And so here, I think if we can click play, maybe.
I think the play would be on your side. Can you?
Oh, got it. Yes, I can do that.
Awesome.
Okay, so we're going. And so you can see that these phytoplankton are moving around in time. And so over time here, you're seeing this is one year cycle. We have lots of different movements of different kinds of phytoplankton in the world, and also a spring bloom that happens once a year, especially around the Arctic and here next to North America. As temperatures warm up, and also you get a lot of movement in the water column that stirs up nutrients. And so actually a lot of people say that if you take 2 breaths, one of those breaths you can attribute to the ocean. And that's because, yeah, we wouldn't be here on this earth today without phytoplankton, because back when the earth was just a big floating rock around the sun, about 500 million years ago, cyanobacteria were some of the first life forms on Earth, and they were what actually created our atmosphere. They were the first organisms to start producing oxygen on Earth, and they're what make Earth livable for us now. And these two, this blue color and the green color, those are both types of cyanobacteria. And so you can see that they're actually hanging out here next to the Bahamas. So that's the dominant type of phytoplankton that we have.
Awesome. Now, I know normally when we go into the ocean, of course, we don't see these colors. So can you explain why these different types of phytoplankton are the different colors on this image?
Definitely. So throughout the world, we have different environments. Some people call them ocean biomes that are more habitable to certain kinds of organisms. And, I was just listening to your episode with Dr. Davis, and like he said, probably not going to find a lion in an agua. And the same way here, that lion needs a certain type of habitat, a certain type of prey, a certain type of temperature. And based on those needs, that's where you're going to find that organism. Yeah, and so in the Bahamas, we're very famous for that clear blue water, and that's because we are in oligotrophic waters, which are low nutrient waters. And that means that we're more likely to have some of these organisms like Synechococcus and Pleurococcus, which actually don't need that many nutrients, but are also really good at taking nitrogen gas out of the air and fixing it into usable nitrogen for other organisms. So that's pretty cool.
That sounds pretty cool. And it
Yeah.
definitely reminds me of these different types of plants. So I love that, people always think that the center of the world is the actual earth and crust, but it really is the ocean, right? Like this is really cool stuff to hear. And even when you talked about how there's a lot of activity going on around the Arctic, we always like to think that, oh, that water's so cold, there's nothing going on there. Can you explain, is that more nutrients in the Arctic water and how?
Yeah, so actually the Antarctic, so that's the southern pole. That's actually the region where I'm most interested in studying and where the organism that I study is found as well. It's also found in the Arctic, but we're interested in the context of it in the southern pole. And you can see that this is such a massive area
All that
of red
red.
here that's dominated by diatoms. And diatoms are a type of cell that have this glass shell around them. And they're really intricate and beautiful, but they're also the big powerhouses of that production of oxygen that I mentioned earlier. So they're very important generally for climate, right?
Right.
Because we as humans, we are producing carbon dioxide and pumping it into the atmosphere. And so far, about a third of that carbon dioxide that humans have generated since the Industrial Revolution has been absorbed by the ocean, and a portion of that is in phytoplankton that has sunk to the bottom of the ocean.
So how are you in Canada studying these phytoplankton in Antarctica?
So what we do, just like many other fields of science, is we bring our subject into the lab and we do experiments to try to understand how they work. So what I do is I take this one species of diatom, which is called Fragilareopsis cylindrus.
I love this name.
And yeah, so you can glean from the name that it's fragile and it's cylindrical.
Right.
And
Scientists
I'll
are
show you
very
this
specific
next.
in their naming.
I'll show you
Um,
this next
this one?
video here. Yeah. And I'm guessing that the reason that this organism ended up getting this name is because of what you see here. And this is a great little video that, are you seeing that okay? Is it moving?
It hasn't started moving on my screen yet.
Okay. Let me try to figure out how to get that to work.
So while they're trying to get that to work, guys, feel free to pop in any questions because I know there's a lot of information coming out. Definitely pop questions to ask them, and we'll definitely answer them before the end of the episode.
Cool. Okay. I'm not sure if I can get this to work.
Let me see. There's nothing on my end that is giving me an option to maybe move it and pop it back up. Sometimes they start playing right away.
Okay.
Oh man.
I think I've got it.
Oh, technology. We were literally
Yes.
talking about this before the episode. I despise technology. If it was up to me, we would be projecting this on a screen somewhere where you guys can come and watch, and we can then just make these larger and project them onto the screen so we can see them move in real time. But alas, we are at the whim of technology, our growing world. And so for those of you that haven't been tuned in this whole time, Catalina is letting us know about their research in phytoplankton, specifically some of the ones that are found in Antarctica, because those ones tend to be actually really cool compared to the ones that are in the Bahamas that can function in this low nutrient water. These ones are actually functioning in water that have higher nutrients that I thought was super fascinating because you don't ever really think of the Antarctic being somewhere nutritious, if I can say that word. So it's exciting to hear how this kid from Abaco ended up in Canada studying phytoplankton in Antarctica. You are all over the world.
Okay, I think maybe we can just skip this one. So what that was supposed to be was a video of this organism actually rupturing as the cells get too warm. Yeah, and so probably the reason why this organism ended up with the name Fragilareopsis is because there were probably some researchers who picked it up in Antarctica and tried to look at it under the microscope in a warm room and saw them explode.
Wow. Is that uncommon for phytoplankton?
Some cells are kind of fragile. Diatoms really shouldn't be though, because like I mentioned, they have that glass shell around them. And so what's interesting about these guys is, you know, they are from Antarctica and they are used to cold temperatures. So as temperatures warm up, they don't do so well. And that leads it to why, you know, this organism is interesting, because it's a very, very important part of that massive red band that I showed you earlier of a lot of phytoplankton conducting photosynthesis in the world and taking up that carbon dioxide. And these guys don't do so well with with increasing temperatures.
Which is currently happening because of climate change. So would it be safe to say that these phytoplankton are almost like that whole analogy of the canary in the coal mine kind of thing?
I would say that these guys are the miners. It's a little bit more dire than that.
Wow.
And it's really hard to know what exactly will happen under climate change, and that is really what myself and a lot of other people are working on right now. But these organisms are so important for the amount of photosynthesis that happens in the world. And we need to know what's going to happen when it does get warmer.
I think it's so crazy that you just said that they are the miners. And for people who are not familiar with that analogy, the canary in the coal mine, it said that miners would take this canary down because canaries are always singing. And when the air started to get too toxic, the canary would be the first to pass out, die, and it would alert the miners to then get out. So the fact that these phytoplankton are the actual miners, it means that there is some other step that we're not even aware of. So by the time that these phytoplankton are affected, it's a little too late.
Yeah, they're doing a very, very important job. And so I guess I'll bring us back to, you know, I told you I study trace nutrient biogeochemistry.
Right.
So how these chemicals are moving around the world, but also trace chemicals. So chemicals that we find in very, very small concentrations in the ocean. And so, you know, if you pick up a bag of fertilizer at your local store to try to make your plants grow, usually you see the letters N, P, and K out on the outside. And those three numbers tell you about the concentrations of nitrogen, phosphorus, and potassium. So those are nutrients that plants need in large concentrations. But there's actually kind of a disproportionate impact on growth of these smaller concentration, either metals or sometimes vitamins. And you know, we as humans as well, we need small concentrations of metals and vitamins so that our bodies can function. And if you never consumed any iron at all in your diet, there would be a big problem. And so we're really interested in how small concentrations of metals and vitamins, in addition to temperature, impact these important phytoplankton.
Right. And so we do have a question coming from YouTube, if you can answer. Kerwin says, I wonder if there's phytoplankton near Antarctica. Antarctica. Why am I stumbling today? Produce more energy with less light. It's interesting. Doesn't that part of the Earth get less sunlight?
That's right. Yeah. And so these guys have really great adaptations for dealing with that. And on top of the fact that the angle of the sun is less direct at the poles, you also have the fact that a lot of this water is covered in ice for a good portion of the year. So for about 4 months out of the year, the light levels under the ice are almost undetectable. And these guys will go into a dormancy for that time usually. where they're not doing much and they're just kind of sitting around waiting for the next cycle of light to happen.
And that would be the spring bloom that you referred to earlier.
Exactly.
And that's so interesting because they're so important and they only really are at their optimal functioning time for this 4 months. And that benefits us for the entire year.
Exactly.
Right. And one of the things that I had advertised about this episode was this is diving into the Euphodic Zone.
Exactly.
Yeah. Can you tell us what is the Euphodic Zone?
So the Euphodic Zone is the section of the ocean. If you're thinking about the ocean vertically from top to bottom, it's the part of the ocean that receives light. And so the reason that I talk about the Euphodic Zone often is because that's where the photosynthesis in the Earth is happening.
Mm-hmm.
Yeah.
Sorry,
please go ahead.
Definitely. And just for people who are just tuning in, I know you had mentioned what percentage of, I think you said the oxygen is coming from the ocean?
So half of the photosynthesis in the world happens in the ocean, and that photosynthesis produces the oxygen that we breathe.
Yeah, because I know I recently did a talk and I was saying that over 50% of the oxygen that we breathe comes from the ocean. So that's a big thank you to all of these little phytoplankton that we don't see. And I think it's unfortunate that with a lot of things that are very important for human life, and of course, I'm coming from this conservationist standpoint, it just seems that we are not putting enough attention to it. And I know we briefly talked about Don't Look Up, this Netflix movie that I think really hit the heartstrings of a lot of conservationists and a lot of people who care about the environment like we do. And do you think, like, given that you just told me that these phytoplankton, so fragile, are the miners in this canary in the mine situation, do you think that you are one of those scientists like Leonardo DiCaprio as that scientist in the movie, just kind of like screaming at the people, trying to get them to listen? Like, do you feel like we're at that point yet with these
Sometimes
phytoplankton?
it feels like it. And, absolutely science is important. And, we spend a lot of time trying to get people to understand why this research is important, but it's really a collaborative effort. So, my hopes are that one day the information that I collect can be incorporated into a climate model, for example. So there are people out there who are crunching numbers to try to figure out what's going to happen under certain climate scenarios. If humans stop producing carbon dioxide today, what does that mean for the future? If we decide to halve our carbon dioxide production, what does that mean for the future? And at the end of the day, that stuff matters, but the most critical and important thing that everyone can do right now is to get involved in policy, because if we don't stop prioritizing profits over the health of the planet, there will be no future.
No planet.
Or at least there will be no future that I will be excited to live in, because the amount of biodiversity that we have access to in the world right now, even just looking at the Bahamas, for example, we have access to so much, and there's still so much to learn from nature. So many of the great inventions that we've had in humanity have come from us looking at the way that nature has evolved and looking at the way that nature has adapted to certain circumstances and applying that to ourselves and using that to develop technology. So if we get rid of all of the stuff that's out there, we don't have that source of information anymore. And I think that's a really, really big shame.
Yeah. And I love how you just put that, because a lot of times when we think of scientists and researchers, I think we almost get pointed as the blame for why, oh, well, if you guys just stop messing with the ecosystem. But no, a lot of times we've only learned things because we've let the ecosystem go undisturbed. We haven't extracted and taken things to the point where it's now you have ecosystems collapsing. And I always like to remind people, we are not separate from this ecosystem. We are very intertwined in this, and we are just not doing a good job at being stewards, which is why the earth is heading in the direction that it is. And fortunately, we have researchers like you that are looking at the little guys that are out there, the phytoplankton, doing their best. And I also, when you had mentioned, if we were to cut our carbon dioxide by half, if we were to reduce that, would we even really see a change fast enough? And I wonder, if at all, during your research, or researchers who may have come a bit before you, has anyone considered looking at did these phytoplankton get affected during the pandemic? I know a lot of scientists saw the Earth kind of take like a nice little, inhale, exhale during the pandemic because we couldn't drive anywhere. Corporations had to close down. Like we had lessened our emissions by so much, proving that it is possible. Like we could do it. Was there any change with the phytoplankton during that time, or was it too small of a window to really kind of?
I think that's a great question. And really, these kinds of things operate on such big time scales, right?
Yeah.
So right now, even we have not seen the complete warming impacts of carbon dioxide that we released 20 years ago. So even if we stop right now, we're still going to see the effects of the past. So, and that's why it's so critical to stop right now.
Like
and
now.
I can imagine someone going back and looking at the historical data in 100 years and maybe seeing that little dip in temperature, and that could be interesting. But I think it would take a little while for us to see that change.
And I think it's just so interesting that, and like you said, in 100 years, someone's going to look and be like, oh, look at during that pandemic, there was just like this little glimmer of hope that happened. And then it just went right back to sugar honey iced tea.
well, I'm going to be positive and say maybe the graph will look like up, 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 dip, and then down.
You know what?
Maybe that'll happen.
Let's err on the side of optimism. I would love to see people take that example from the pandemic and just to live more sustainably. I know I see a lot more people these days taking an active effort in their health. I'm seeing people outside exercising and trying to, keep their bodies functioning. So let's take that same attitude with our planet. Let's use this time to like slowly come back into gear. And even just maybe things that you weren't doing before, you had to stop because of the pandemic. Consider how important it was to drive 3-4 times a week to go somewhere when you can just do something like corporations. Let your people work remotely for a couple of days out of the week, save that. But so I know you started to touch a bit about how viewers can get involved. You were saying policy. Are there other ways that they can get involved, maybe with your research directly? For any viewers who might be interested in studying this themselves, can you give us some more information about maybe your lab and some of the stuff that is going on over there in Dalhousie?
Absolutely. I mean, so Dalhousie is such a great school, I think, especially for Bahamians because we're right up the coast and there are a lot of us. So definitely, if there's anyone that's interested in learning more, either about what I work on, or if you're just a young Bahamian out there who is just looking to get into academia or into marine ecology, into conservation, I'd love to have a chat with you because I definitely was in that same situation a couple of years ago, and I had lovely people who were able to provide guidance and be that support system for me.
Yeah, that's what it's all about. We got to make connections because I think in the past, and we always talk about it, any Bahamian that was interested in anything science related, immediately go be a doctor. Go be a doctor. And yes, some of us can go be a doctor, but some of us, like yourself, are actually interested in things like seaweed and what's going on in the water and what's happening at this microscopic level. So thank you so much for doing that. First of all, this is such a big task to take on. And I know sometimes it can get so depressing seeing that nobody's listening. Like, don't look up, but somebody's listening. So as you go through your studies, I do wish you all the best. But do you have any final thoughts for viewers? Like maybe some lessons learned so far in your career?
Definitely. I think one of the most important things that I've learned, but I also have been wanting to try to exercise increasingly, and I'm still working on this every day, is allowing myself to make mistakes. I think, especially with social media, we see a lot of people out there who we want to believe have perfect lives and, got that scholarship and got into the perfect school and everything goes really well for them. But the truth is that we don't really share our failures enough. And so making mistakes is such an important part of science, but also part of life. If you don't try something and figure out if it works for you, if it doesn't work for you, you'll never have tried it. So I really encourage people out there to, if there's anything that seems scary or intimidating, jump right in. Of course, stay safe. But if you think that a situation feels uncomfortable and it's discomfort for fear of failure, go for it. Just do it.
Right. And just like, I'm going to pop that back up. My Aunt Denise, one of my faithful viewers, that is a very interesting quote because I think, like you said, a lot of times, especially just in life, like people don't want to share their failures. People don't want to share their mistakes. And even in science, I know I recently learned about this website called conservationevidence.org when I was in my master's program. And this whole site, and I hope I quoted that website properly, is focused on people's like asking and reaching out to researchers. Can you please share your failed experiments, your failed things, so that people who are maybe considering doing some of these things can learn and maybe even improve on that. And it's so important to know, like, maybe someone did try this and maybe they figured out a way to do it better, to then help with the progression of man, progression of science, progression of people, just by hearing these mistakes, because one little mistake may trigger a thought in someone's mind. So I love that. And I love that just in life and just living life to the fullest, it's so important to not let fear be the thing that stops you, right?
Absolutely. Yeah. And when I often now I train students on how to grow these organisms in the lab. And I always show them like my first really, really, really bad and embarrassing experiment where all of the different cells are doing like this. They're supposed to be in a nice, neat little line, but they're all over the place. And, I have to say, like, your first time doing something is not going to be perfect. And like, you have to make mistakes in order to progress.
I love that. I actually I should get Headspace to sponsor me, because it's an app that gives you insightful meditation, mindfulness. And one of the things that recently was talking about is having a beginner's mindset. Like, don't feel like the minute you start something new that you're supposed to be excellent at it, you're supposed to be perfect. There are people who are going to do things in science, in life, in careers where they immediately get it right away and they're like this natural born star at something. But that's not everybody. And that's not the average. So do not ever be discouraged because you try something once or twice or even 10 times and it's still not great, because practice makes perfect. Trial and error is what moves us forward as people. So I love that. Having a beginner's mindset is so important. Allow yourself to make a mistake. Just do not allow yourself to give up. But before we go, I'm super interested now to hear who is somebody in the sector, either locally or internationally, Bahamian or not, that has inspired you, and why have they?
Oh gosh, there's a big list of people. Definitely, I'd have to say, I'm just going to rattle off some names real quick. Dr. Davis, who I've been following for a long time on social media, and I just think his content is so neat, and I love what he does. Dr. Diane Claridge, Dr. Charlotte Dunn at BIMRO, if you have heard of those two.
Yes, I have. I love so them. Yeah. I'm trying to get them on the show.
That's a great idea. You should. They would be awesome.
Definitely.
But I think one person, especially in specifically in marine microbiology, that I've really been looking up to lately is Dr. Tierra Moore. And she's actually the head of Black in Marine Science. And she calls herself a forensic ecologist. So she does work that's pretty similar to mine, or did for a few projects, but also just, championing for Black folk in marine science, because a lot of us grow up with this idea that, Black people can't swim, Black people can't dive, Black people don't like to be outside. And that's just, not true. And we deserve those experiences just as much as anybody else.
I love that you said that, because when I recently got connected with BIMS, I fell in love with this entire concept, because the same thing, right? And you hear it a lot in the Bahamas. You want to do what? You're going to be in the sun. You can get darker. You don't care about how your skin looks. Your hair is always going to be wet and curly. And I think it's so beautiful that she started this. It's Dr. Tierra Moore. I think her handle is @curly_scientist.
Oh, yeah.
Right. Because I follow her too. And I'm a big fan. Took this concept of Black in marine science. For those of you who've never heard of it, it's BIMS. I think they're on all social media platforms at this point. Instagram, Twitter, Facebook. It really opens up that door to connect Black marine scientists, but also to inspire young Black kids who want to get involved in marine science. So I'm glad that you brought her up. That's a great plug for her. And I definitely want to make sure that she knows that we talked about her on this episode.
I know. We should tag her.
I'm going to. I definitely will.
Exciting.
Awesome. Do you have any final words for our guests as we sign off on another wonderful episode?
No, I just wanted to say thanks everyone for listening, and thanks for having me, Lashanti. It was such a pleasure. Your show is amazing.
Thank you so much for being on this episode. It's been so lovely having you. Thank you, everyone who's been riding this wave with us for another episode of Siren Sundays. To all of my live viewers and to all of you who are listening on the podcast, remember you can get this on all platforms right now on our podcast feature. Hope to see you soon. All waves yours, Lashanti the Siren. Bye, everyone.